According to the National Electrical Code, looping and splicing grounds in non-metallic boxes with a red wire nut is not legal. National Electrical Code Article 250.126 states that in enclosures where grounding by grounding connection is not provided, grounding must be achieved by one of the following methods. Firstly, equipment grounding conductors connected to a metal enclosure. Secondly, metal raceways. Thirdly, an equipment grounding bus. And fourthly, a grounding electrode conductor. National Electrical Code Article 314.17 addresses the grounding of receptacles, requiring that all receptacles be grounded by connecting a grounding conductor to the receptacle's grounding terminal. The grounding conductor is intended to offer a low impedance path to ground for fault currents. Looping and splicing the ground wire with a red wire nut might introduce additional resistance and inductance, potentially reducing the grounding system's effectiveness. Approved methods for grounding include using a copper crimp which connects the grounding conductors together with a mechanical connection that ensures a secure and reliable connection. Another approved method is using a green wire nut. Green wire nuts are specifically designed for connecting grounding conductors and are typically made of a material that will not corrode or loosen over time. Inspectors have the authority to enforce the National Electrical Code and any local codes or regulations. They might require the use of specific materials or methods, even if they are not explicitly stated in the National Electrical Code. It is strongly recommended to follow the inspector's instructions and use an approved method of grounding. Failure to do so could result in a failed inspection or potential safety hazards. Understanding the specific requirements outlined in the National Electrical Code is crucial for ensuring electrical safety and compliance. Article 250.126 delineates acceptable grounding methods in enclosures where a direct grounding connection is absent. This section ensures that an alternative grounding path is established, maintaining safety standards even when typical grounding means are unavailable. The allowed methods detailed in Article 250.126 provide flexibility in various installation scenarios while upholding the integrity of the grounding system. These alternatives are designed to provide a reliable and safe electrical connection, preventing potential hazards. Article 314.17 emphasizes the necessity of grounding all receptacles. This grounding is achieved by directly linking a grounding conductor to the grounding terminal of the receptacle. This direct connection is vital for diverting fault currents safely, preventing electrical shocks, and minimizing the risk of damage to equipment. The requirement in Article 314.17 is fundamental to electrical safety, ensuring that any fault current is immediately directed to ground, thereby activating the circuits over current protection. Using a copper crimp offers a mechanically sound and electrically reliable connection. This method ensures that the grounding conductors are tightly joined, minimizing resistance and providing a clear path for fault currents. The durability of a copper crimp connection makes it ideal for long-term reliability, reducing the need for frequent maintenance or replacements. Copper crimps are specifically designed to withstand the rigors of electrical environments, maintaining their integrity over time. Green wire nuts, engineered specifically for grounding purposes, provide a secure and corrosion-resistant connection. The design ensures that the grounding conductors are held firmly together, preventing loosening or disconnection. The materials used in green wire nuts are selected for their resistance to corrosion, ensuring a lasting and reliable connection in various environmental conditions. These wire nuts are an essential component in maintaining the integrity of the grounding system. Inspectors, as the authority having jurisdiction, play a critical role in ensuring that electrical installations meet safety standards. Their decisions are based on the National Electrical Code and local regulations, and their interpretations carry the weight of law. Inspectors have the power to enforce the code, ensuring that installations are safe and compliant. This authority is essential for protecting the public and preventing electrical hazards. Compliance with the inspector's instructions is paramount. Their guidance ensures that the installation meets the required safety standards and that potential hazards are avoided. Failure to comply can result in failed inspections, rework, and potential safety risks. Following the inspector's advice is a crucial step in achieving a safe and compliant electrical installation. The integrity of the grounding system is paramount for electrical safety. A well-designed and properly installed grounding system provides a low-impedance path for fault currents, protecting people and equipment. The effectiveness of the grounding system is critical for preventing electrical shocks, fires, and damage to sensitive electronic equipment. Maintaining the integrity of the grounding system is a fundamental aspect of electrical safety. Understanding impedance in grounding systems is key to ensuring their effectiveness. Impedance, which includes both resistance and inductance, affects the flow of fault currents and the speed at which protective devices operate. High impedance can reduce the effectiveness of the grounding system, delaying the response of circuit breakers and increasing the risk of electrical hazards. Maintaining a low impedance path to ground is crucial for ensuring rapid and effective fault current dissipation. The material composition of grounding connectors, such as copper crimps and green wire nuts, is critical to their performance and longevity. Copper crimps provide a reliable connection due to copper's excellent conductivity and resistance to corrosion. Green wire nuts are made from materials that resist corrosion and maintain a secure connection over time, ensuring long-term reliability. Selecting appropriate materials for grounding connectors is vital for maintaining the integrity of the grounding system. Mechanical connections in grounding systems, like those provided by copper crimps, offer a secure and reliable means of joining conductors. These connections are designed to withstand mechanical stress and vibration, ensuring that the grounding path remains intact. A well-executed mechanical connection minimizes resistance and prevents loosening over time, enhancing the overall effectiveness of the grounding system. Mechanical connections play a vital role in maintaining the integrity of the grounding path. Corrosion resistance is a key factor in the longevity and reliability of grounding connections. Corroded connections can increase resistance and reduce the effectiveness of the grounding system, potentially leading to electrical hazards. Selecting materials and methods that resist corrosion is essential for ensuring long-term performance and safety. Corrosion-resistant connections are a critical component of a robust grounding system. The role of local codes and regulations in electrical installations cannot be overstated. These codes often supplement the National Electrical Code, addressing specific local conditions and requirements. Compliance with local codes is mandatory, and inspectors are responsible for enforcing these regulations. Understanding and adhering to local codes is essential for ensuring a safe and compliant electrical installation. The grounding electrode conductor plays a crucial role in connecting the grounding system to the earth. This conductor provides a path for fault currents to dissipate into the ground, reducing the risk of electrical shock. The size and material of the grounding electrode conductor are specified in the National Electrical Code to ensure its effectiveness. A properly installed grounding electrode conductor is essential for a safe and reliable grounding system. The equipment grounding bus provides a central point for connecting equipment grounding conductors. This bus ensures that all equipment is effectively grounded, minimizing the risk of electrical shock. The equipment grounding bus is typically located in the electrical panel and is connected to the grounding electrode conductor. A properly installed equipment grounding bus is a key component of a comprehensive grounding system. Metal raceways can serve as equipment grounding conductors, providing a continuous grounding path throughout the electrical system. This method relies on the conductivity of the metal raceway to safely carry fault currents back to the source. Properly installed and maintained metal raceways can offer an effective and reliable grounding path. The National Electrical Code provides detailed specifications for the use of metal raceways as grounding conductors. Equipment grounding conductors connect non-current carrying metal parts of electrical equipment to the grounding system. These conductors provide a low impedance path for fault currents, protecting people and equipment from electrical shock. The size and type of equipment grounding conductors are specified in the National Electrical Code to ensure their effectiveness. Properly installed equipment grounding conductors are essential for electrical safety. Understanding the concept of a low impedance path is crucial for effective grounding. A low impedance path allows fault currents to flow quickly and easily back to the source, tripping circuit breakers and preventing electrical hazards. High impedance can impede the flow of fault currents, delaying the response of protective devices and increasing the risk of electrical shock. Maintaining a low impedance path is a fundamental principle of electrical safety. The overcurrent protection devices, such as circuit breakers and fuses, play a critical role in the grounding system. These devices are designed to trip quickly when a fault current is detected, interrupting the flow of electricity and preventing electrical hazards. The proper coordination of overcurrent protection devices with the grounding system is essential for electrical safety. Circuit breakers and fuses are key components of a comprehensive electrical safety system. The consequences of a failed inspection can be significant, including delays in project completion, rework, and potential fines. A failed inspection indicates that the electrical installation does not meet the required safety standards and must be corrected. Addressing the issues identified during the inspection promptly is crucial for ensuring a safe and compliant installation. Avoiding failed inspections requires careful attention to detail and adherence to the National Electrical Code and local regulations. Potential safety hazards associated with improper grounding include electrical shock, fire, and damage to equipment. Electrical shock can occur when a person comes into contact with a live electrical conductor. Fire can result from overheating due to excessive fault current. Damage to equipment can occur when sensitive electronic devices are exposed to voltage surges. Proper grounding is essential for mitigating these risks. Electrical safety is paramount in all electrical installations. Proper grounding, adherence to the National Electrical Code, and compliance with local regulations are essential for protecting people and property from electrical hazards. Taking the necessary precautions and following best practices can significantly reduce the risk of electrical accidents. Electrical safety should always be the top priority. The long-term reliability of grounding systems depends on proper installation, maintenance, and the use of high-quality materials. Regular inspections can help identify potential problems before they become serious. Addressing any issues promptly and maintaining the integrity of the grounding system is essential for ensuring long-term safety and performance. A well-maintained grounding system provides continuous protection against electrical hazards. Understanding the National Electrical Code is essential for anyone involved in electrical work. The National Electrical Code provides comprehensive guidelines for safe electrical installations, covering a wide range of topics from grounding to wiring methods. Familiarity with the National Electrical Code is crucial for ensuring compliance and preventing electrical hazards. The National Electrical Code is a valuable resource for electrical professionals. Continuing education and training are essential for staying up to date with the latest changes to the National Electrical Code and best practices in electrical safety. The electrical industry is constantly evolving, and it is important to stay informed about new technologies and regulations. Continuing education and training can help electrical professionals enhance their skills and knowledge. Investing in continuing education and training is a valuable investment in electrical safety. Consulting with qualified electrical professionals is always recommended when dealing with complex electrical installations. Qualified electrical professionals have the knowledge and experience to ensure that the work is done safely and correctly. Hiring a qualified electrician can help prevent electrical hazards and ensure compliance with the National Electrical Code and local regulations. Consulting with experts is a smart investment in electrical safety. The grounding system's performance can be evaluated through testing and measurement. Ground resistance testing can verify the effectiveness of the grounding electrode system. Impedance measurements can assess the overall impedance of the grounding path. Regular testing and measurement can help identify potential problems and ensure the continued effectiveness of the grounding system. Testing and measurement are valuable tools for maintaining electrical safety. Ensuring equipotential bonding throughout the electrical system minimizes voltage differences and reduces the risk of electrical shock. Equipotential bonding connects all metal parts of the electrical system to the grounding system, creating a common ground potential. This helps to prevent dangerous voltage differences that can occur during a fault condition. Equipotential bonding is an important aspect of electrical safety. Surge protection devices play a vital role in protecting sensitive electronic equipment from voltage surges. These devices divert surge currents to ground, preventing damage to connected equipment. Surge protection devices should be installed at the service entrance and at sensitive equipment locations. Surge protection is an important layer of protection in the electrical system. The grounding of electrical services, such as the main electrical panel, is critical for safety. The service grounding system connects the neutral conductor to the grounding electrode system, providing a low impedance path for fault currents. Proper service grounding is essential for preventing electrical shock and ensuring the proper operation of overcurrent protection devices. Service grounding is a fundamental aspect of electrical safety. In summary, grounding in non-metallic boxes requires adherence to specific methods outlined in the National Electrical Code. Using copper crimps or green wire nuts ensures secure and reliable connections, while red wire nuts are typically not approved for grounding purposes. Following the inspector's guidance and complying with local codes are essential for maintaining electrical safety and passing the inspections. A properly installed and maintained grounding system is crucial for protecting people and equipment from electrical hazards. Remember to always prioritize safety and consult with qualified professionals when dealing with electrical installations. Electrical work can be dangerous, but by following the guidelines set forth in the National Electrical Code and local regulations, you can minimize the risks and ensure a safe and reliable electrical system. Grounding is a fundamental aspect of electrical safety, and a thorough understanding of the principles and best practices is essential for anyone working with electricity. By staying informed and following the correct procedures, you can help to prevent electrical accidents and protect yourself and others from harm. Electrical safety is a shared responsibility, and it is important to take it seriously. In addition, make sure to note that the requirements for electrical installations can vary depending on the specific location and application. It is always best to consult with a qualified electrical professional who is familiar with the local codes and regulations. They can help you to design and install a safe and compliant electrical system. Remember that electricity is a powerful force, and it should be treated with respect. By following the proper procedures and taking the necessary precautions, you can work safely with electricity and avoid potential hazards. Electrical safety is a lifelong commitment, and it is important to stay informed and up to date on the latest best practices. By doing so, you can help to create a safer environment for yourself and others. Grounding is a critical component of any electrical system, and it is essential to ensure that it is installed and maintained properly. A well-designed and properly functioning grounding system can help to prevent electrical shock, fire, and damage to equipment. By following the guidelines set forth in the National Electrical Code and local regulations, you can help to ensure that your electrical system is safe and reliable.